During a 40-mile trip, Marla traveled at an average speed of x miles per hour for the first y miles of the trip, and at an average speed of 1.25x miles per hour for the last 40 minus y miles per trip. For the last 40 minus y miles of the trip, the time that Marla took to travel the 40 miles was what percent of the time it would have taken her if she had traveled at an average speed of x miles per hour for the entire trip. So I'm going to start without looking at the statements. Now, what we've got here is y miles, our distance, is equal to x miles per hour times t1 hours. So that would imply that t1 equals y over x. Furthermore, we know that 40 minus y miles is equal to 1.25x, but it's going to be easier to write that as 5 over 4x miles per hour times t2 hours. All right, so that implies that t2 then is 40 minus y times 4 over 5. And if we expand that out, that's going to be 160 minus 4y over 5x. Let's think about what the question's actually asking. So the time that Marla took to travel the 40 miles was what percent of the time it would have taken her if she had traveled at an average speed of x miles per hour for the entire trip. So basically we're looking at t1 plus t2 over the time at x miles. So what I'll do there is I'll just say that that's t1 plus t2 over t3. And that should give me something like y over x t1 plus 160 minus 4y over 5x. And then divide that all by t3. Okay, so I want to find a common denominator here. So that's going to be 5y over 5x. And that's 160 minus 4y. So let's just clean that up a little bit. So we get 160 plus y over 5x, and the whole thing is divided by this t3. So now, remember, I still haven't looked at the statements, but I'm considering the hypothetical statement here. 40 miles as a distance. If she had traveled x miles per hour the entire time, that's going to be our t3 hours, okay? That means that t3, of course, is 40 over x. I'll plug that in here. So now I'm going to get 160 plus y over 5x divided by 40 over x. And if we flip that over, we're going to get 160 plus y. So notice that the x actually disappears. And we need to solve for y. We need to have y figured out. So what we need then is we need to figure out, okay, well, if x is 48, that's not really helpful because the x disappears. So we don't need to say that. However, we've got y equals 20. That is useful because then we get 180 miles as the answer. So the answer should be B, statement 2 alone. Now the reason that that's the case is because the x fell out. So be careful about that. That when the x falls out, the x cancels all the way out, then we don't actually need ever to know what it was. It's completely irrelevant what it happened to be. The answer is going to include y, so of course we need to know what y is. Therefore, knowing why, statement 2 is enough to solve. If you like this video, the best way to support the channel is to click the like button or subscribe on YouTube. And if you look at the little information box in the top right corner, you'll see that there's a link to a free 23-page PDF guide on properties of numbers. If you're having trouble with those properties questions, I know they can be annoying, just click on the link, download the guide, and that will set you off on the right foot with learning how to solve properties of numbers questions correctly. Thanks for watching, and I'll see you in the next video.